Today, we're diving into an exciting topic in physics: circular motion. You see, we're surrounded by objects moving in circles, from planets revolving around the sun to the tires on your bike. But what exactly happens when something moves in a circle? Let's break it down. When we talk about circular motion, we mean the movement of an object along the circumference of a circle. The key thing to remember here is that the direction of the object is constantly changing, even if its speed remains the same. This change in direction brings us to the concept of centripetal acceleration, which we'll explore more in a bit. To understand circular motion better, there are a few key terms you need to know. First is the radius, which is the distance from the center of the circle to any point on the circumference. Then we have velocity. In circular motion, velocity is always tangential to the path, meaning it's perpendicular to the radius at every point. Next, we have angular velocity, which measures how fast the object is rotating around the circle, and it's expressed in radians per second. And most importantly, we have centripetal force. This is the force that keeps the object moving in the circle and is directed towards the center. Without centripetal force, the object would fly off in a straight line. The formula for centripetal force is where is the mass, is the velocity, and is the radius. Let's take a simple example to understand this better. Imagine you're swinging a ball attached to a string. The ball moves in a circular path. The tension in the string provides the centripetal force that keeps the ball in motion. If you let go of the string, the ball flies off in a straight line. This shows that an inward force is needed to keep the ball moving in a circle. Another example would be a car taking a turn on a curved road. The friction between the tires and the road provides the centripetal force that keeps the car moving in the curved path. Without this friction, the car would skid outward. There are also two types of circular motion. In uniform circular motion, an object moves around the circle at a constant speed, but its velocity is constantly changing due to the change in direction. In non-uniform circular motion, the object's speed varies as it moves along the circular path, so it experiences both tangential and centripetal acceleration. You might also have heard of centrifugal force, especially when you feel like you're being pushed outward while taking a sharp turn in a car. While it feels like a real force, centrifugal force is what we call a pseudo-force. It only appears when we observe motion from a rotating reference frame. The actual force that keeps you moving in a circle is the centripetal force, which is always directed towards the center. And that's the basics of circular motion. It's all about the changing direction, the forces at play, and the acceleration involved. I hope this video helped clarify the concept for you. If you found it useful, make sure to like, subscribe, and hit the notification bell for more physics content. Thanks for watching, and I'll see you in the next one.